Exercise 7.2 Problem 4 Discussion. To find the cloud ceiling, one night an observer directed a spotlight vertically at the clouds. Using the theodolite placed 100 meters from the spotlight and 1.5 meters above the ground, he found the angle of elevation to be 60 degrees. How high was the cloud ceiling? Okay, note, cloud ceiling is the lowest altitude at which solid clouds is present. It's quite a bit of heavy cloud actually. The cloud ceiling at airports must be sufficiently high for safe takeoffs and landings. At the night of the ceiling, the night ceiling can be determined by illuminating the base of the cloud by a spotlight pointing vertically upward. Okay, let's not worry too much about it. Let's make a simple diagram. So this is the cloud, and point C is on the ground. EC is the ground level. Okay, so from C, a light is spotlight is vertically directed, so it will go and hit the cloud, and this will get illuminated. Now what they are doing is that they are keeping a theodolite here. The theodolite is kept at about 1.5 meters above the ground. Okay, and then theodolite is basically to measure the distance between 2 points, angles and everything. It's a civil engineering instrument. So from here this will be the reference. The horizontal level will be the reference, and then they will focus on the cloud, and from these two they will be able to get the angle of elevation. That is, this is the angle of elevation, right? So this theodolite will be able to give, and this they have found it to be 60 meters, and the theodolite is 1.5 meters above the ground level. You got it? So let me repeat. CE is a ground level, and A is a cloud, and B is where the spotlight is directed vertically upwards. So this light will go and hit the cloud, and from here the theodolite, using a theodolite, they are trying to find the angle of elevation. So how will they find the angle of elevation? They will first look in the horizontal direction, and that will be taken as 0. Then they will rotate it up till they are able to see the cloud, and from the angle of rotation they are able to give us the angle of elevation. Okay. Now what is the question? The question was, how high was the cloud ceiling? That is, we want to know AC. Okay, but see here, DE is 1.5 meters, which means BC is also 1.5 meters. It's a parallel line. This line is parallel to the ground level, right? So BC is 1.5 meters. So all we need to find is AB. Okay, and this EC is 100 meters, which means DB is also 100 meters, or BD is also 100 meters. Okay, so it's very simple. This is also, because these two are parallel. These two are parallel, and this line is parallel. So this is also 100 meters. Now you want to measure AB, and you are given this, and you are given this angle. So tan 60 will help us. What is tan 60? Tan 60 is opposite by adjacent. That is AB divided by BD. So from this equation you will be able to get AB. Once you get AB, then AB plus BC will give you the total height. And as I told you earlier, BC is nothing but 1.5 meters. Okay, so this is how the problem will be solved. Now let's go through step by step. Okay, let's mark what is given. The theodolite is placed 100 meters from the spotlight, and it is 1.5 meters above. See, that's what I'm saying. This is from this spot. This is a spotlight, so it's placed 100 meters away, and this is 1.5 meters above the ground level. He found the angle of elevation to be 60 degrees. So that is, from sitting here, they found, using the theodolite, they found the angle of elevation. So angle of elevation is basically from here, if you look up that line, and the angle with the horizontal line. Horizontal line is nothing but your eye level, right? A horizontal line through your eye level. So this is 60 degrees. So that they have found. Okay. Then what is asked? You are asked to find the height of the cloud ceiling. Right? Let's test it out. So angle of elevation, distance of the theodolite from spotlight, position of the theodolite above ground. Need to calculate height of the cloud ceiling. Formula: tan theta is opposite side by adjacent side. Okay. Now let's first step, draw a rough diagram, label and mark the diagram with given values. Okay. Substitute angle of elevation, distance of theodolite from the spotlight in tan theta equal to opposite side by adjacent side. So this is a formula which we need to use. Tan theta is opposite side by adjacent side. But what is it in this case? Tan theta is tan 60. That is equal to opposite side is AB and adjacent side is nothing but BD. But what is BD? BD is the distance of the theodolite from the spotlight, right? So in this case AB we don't know, and distance from the theodolite we know that it is 100 meters, and tan theta is tan 60. We know the value of tan 60, that is root 3. So this is known, this is known, so from which this can be calculated. So we will be able to calculate AB. What is AB? This portion. Now next step is that we need to calculate the height of the cloud ceiling. So what is height of the cloud ceiling? That is AB plus BC. But we know BC is nothing but DE. So AB which was calculated, add 1.5 to it, that is your height of cloud ceiling. You got it? Let me repeat. So this is a theodolite here. This is a spotlight. This is a cloud. So the light is directed vertically upwards to the cloud. Here is a theodolite which is 1.5 meters above ground. So this is your ground level, and this is the horizontal line, okay, or the eye level. Then they point it towards the cloud and they find the angle of elevation which is 60 degrees. Angle of elevation is always between the line of vision and the horizontal line. So this is 60 degrees. So this tan 60 will give you opposite by adjacent. So this adjacent side is known as 100 meters. This AB can be calculated. So once AB is calculated, AB plus BC will give you the total height of the cloud ceiling. Okay. So I hope I made it clear. What I suggest is pause the video here and try to do the problem on your own, and on completion please come back and check your working against our solution. Okay, now let A, C, D represent the cloud, spotlight and the theodolite. A is a cloud, B is C is the spotlight, and D represent the theodolite. Given, what is given in our case? That is the distance of the theodolite, horizontal distance from the theodolite, that is CE. This is your ground level, right? CE is 100 meters. And the theodolite is placed 1.5 meters, that is DE is 1.5 meters. And the angle of elevation is 60 degrees. Okay, draw a vertical parallel line to the ground level. So this angle is 60 degrees. So in triangle ABD, tan 60 is AB by BD. Right, so that will be, so which means AB is what we need to calculate. And what is BD? BD is 100. BD is CE, right? So that is 100 meters. So AB by 100 equal to tan 60. Tan 60 is root 3. So from this we get AB will be equal to 100 into root 3. That is 1.732 into 100. That is 173.2 meters. So cloud ceiling is this plus 1.5 meters. Because this is only, we have got only this bit AB, but the height of the cloud ceiling is AC. So that is AB plus BC. BC is 1.5 meters. So that is 173.2 plus 1.5 meters. So that is 174.7 meters. Okay. So I hope I made it clear. If not, please go through this video one more time. It will become clear. Thanks for watching this video.